Hello everyone, my name is Sudheer Kumar, working as an Assistant Professor of Mathematics, MLR Institute of Technology. In this lecture, we are going to cover these topics: echelon form, rank of matrix, normal form, rank of matrix by using normal form, and how to find the inverse of matrix by using Gauss-Jordan method. Let us see echelon form definition. A matrix is said to be in echelon form if it satisfies the following properties. First one, zero rows. If any matrix having zero row means all the elements of a row are zero, then we call it as zero row. So if any row having zero rows, that should be below any non-zero row. Means first row of any matrix should not be having zero row. That should be below the non-zero row. Next, second point, the first non-zero entry in each non-zero row may be equal to 1. It's not compulsory. If it is equal to 1, then we can make it easily to find the echelon form. The first non-zero entry should be equal to 1. Third point, the number of zeros before the first non-zero element in a row is less than the number of such zeros in the next row. Means number of zero before the first non-zero element. See here, this is the first non-zero element in that row. This is in second row. Before that, how many zeros are there? Only one zero. Whereas in third row, this is the non-zero element, isn't it? Before this, we have two zeros. So first row we have only 1 0, second row 2 zeros, third row 3 zeros before the first non-zero element in that particular row. So in every row we have number of zeros is less than the number of such zeros in the next row. Then we call it as echelon form. Say for example, this is the matrix 3 0 14 4 0 1 0 1 0 0 3 1. This is said to be in echelon form. Below the diagonal elements must be equal to 0. Above the diagonal element, we don't bother. Below the diagonal elements, the elements must be 0. Here we say that the rank of matrix is 3. Rank of matrix by using echelon form is number of non-zero rows. Here we have 3 non-zero rows, so we say that the matrix is having rank 3. Now let us find the rank of matrix using one example. Find the rank of the matrix by reducing it to row echelon form. To reduce the matrix into echelon form, we use only row operations, not column operations. So A equal to, this is a 3 rows and 4 columns. This is the dimension of the matrix is 3 by 4. To make it or to reduce the given matrix into echelon form, first of all I need to make this element 0 and this element 0. To make this element 0, the operation should be R2 minus 2R1. So 2 minus 2 into 1, this is 0. Next, to make this element 0, the operation should be R3 tends to R3 minus 3R1. So 3 minus 3 into 1. So these are all elements of R1, R2, R3, third row, right? So second row elements, you can check it, 2 minus 1 into 2 into 1, 0. 4 minus 2 into 2, 4 minus 4, 0. 6 minus 6, 0. 8 minus 8, 0. Third row elements, R3 minus 3R1, 3 minus 3 into 1, that is 0. Next, 6 minus 3 into 2, that is 0. Next, 9 minus 3 times of R1, that is 0. So we got second row, third row completely zeros. So how many non-zero rows we have? This is the only first non-zero row. So the rank of the matrix is 1. According to the row reduced echelon form, number of non-zero rows defines the rank of the matrix. So here the rank of the given matrix is 1. Next, normal form of a matrix. Normal form can be represented as identity matrix IN000 or identity matrix 0 or identity matrix. Even any one of these 4 forms we can represent the normal form. In normal form, we apply row operations as well as column operations, whereas in echelon form we apply only elementary row transformations. In normal form we use both row operations as well as column operations. Let us see how to convert the given matrix into normal form and find its rank. So determine the rank of a matrix, say by reducing into normal form. So normal form means I have to get completely identity matrix. So first of all, I have to get zeros at this place and this place to reduce the matrix into echelon form. I apply operations on R2 minus 2R1. Apply operations, row operations on R3 minus 3R1. So how will you get 1, 2, 3 first row as it is? I am not changing any first row elements. Second row elements 2 minus 2 into 1 0. Next 4 minus 4 0. 7 minus 2 times of R1, 7 minus 6 we get 1. Coming to R3 minus 3R1, third row, here we have first element R3 minus 3 times of R1, so 3 minus 3 is 0. Next 6 minus 3 times of R1, 6 minus 6 0. So we got completely third row as 0. Now our aim is to reduce into normal form. Now using some column operations, the given matrix is reduced like this. Again interchanged first column and third column, we get this. So we completely got identity matrix of size 2 by 2. This is the 2 by 2 matrix, that's why I am writing I2. Identity matrix of size 2, remaining all elements are zeros. So we call the rank of the matrix is 2. Right. Let us see one more example to find the rank of the matrix by reducing it to normal form. Reduce the matrix to its normal form and determine its rank. So first let us make this element 0 and this element 0 by using row transformations. I apply R2 minus 2R1 on second row to make this element 0. R3 minus 2R1 on R3 to make this element 0. So we got these 2 rows by using these 2 row transformations. Next I apply column operations so that I have to get these 2 elements also zeros. So this is in third column, this is in fourth column. So I apply operations on C3 and C4 so that this element and this element I got zeros. Next, using operation on R3 minus 3R2, I get 0, 0, 2, 2. Now R3 tends to 1 by 2 of R3. Since I want identity matrix, means 0, 0, 1, 0. So here we have 2. So we are dividing R3 with 2. So we get 0, 0, 1, 1. Now coming to C3 tends to C3 plus C2. Here we have third column 0, minus 1, 1. But I want 0, 0, 1. So this is second column, this is third column. Add these two columns, then we get C3 elements, which is 0, 0, 1. At last, I am getting the last column elements as 0. So this is the matrix of identity matrix 3. So we get I3, 0. So this is in standard normal form. In general, we represent it as IR comma 0, where R is the rank of the matrix. Here I3 comma 0, remaining all elements are 0. So rank of matrix is 3. Now coming to Gauss-Jordan method. For the given matrix, to find the inverse of matrix, we apply Gauss-Jordan method. Let us see how to find the inverse of matrix. Let A be a non-singular square matrix of order n. Non-singular means determinant not equal to 0. Let B be the inverse of A. Why I am writing non-singular? If it is singular matrix, determinant 0, so inverse does not exist. So that's why let us take non-singular square matrix of order n. And B is the inverse of A. If I write A into B is equal to I, we say that B is the inverse of A, isn't it? So in place of B, I write A into IN or IN into A. If this is equal to A, we say that the matrix here is the inverse of A. So first let us consider A equal to IN into A. Since A is non-singular, we first pre-multiply the sequence with elementary matrices, only row operations, right? We apply only row operations on both sides of A, and A on the left side of A, that is transformed to identity matrix n. At last we get the matrix of the type IN equal to BA. So we say that B is the inverse of A, or A inverse equal to B. Let us illustrate this with some example. Find the inverse of this matrix using Gauss-Jordan method. So to apply Gauss-Jordan method, first we can write A is equal to I. Here the dimension is 3 by 3, so we write it as A3, A into I3, right? If it is 4 by 4 matrix, we write it as A into I4, right? So using these operations, first let us, first row, I want this element should be 1. Completely this left side matrix should be identity matrix. Using only row operations, we convert this matrix into identity matrix. So whatever matrix we get here, we call this is inverse of A. Whatever row operations we are applying on this matrix, the same row operations need to be applied on right side matrix also. So next, coming to second row, I want this element 0 and this element 0 to make it identity matrix. So R2 minus 3R1 and R3 tends to R3 minus 2R1. So I get this second row here, third row, both are zeros. The same row operation should be applied on this right side matrix also. So we get this matrix. Now I want the matrix should be identity matrix. So I apply R2 tends to 2 times of R2. Here we get 1 by 2 minus 1 by 2. To get 1, need to multiply with 2. So we get this. The same row operations should be applied on right side matrix also. So we get this matrix. So at last the matrix can be written as identity matrix I into some matrix B. So A is equal to identity matrix into B. So we say that, so B equal to A inverse, right? So A inverse is 3 minus 1. Whatever matrix we get here right side, that is the matrix which is the inverse of the given matrix. So in this lecture we have covered echelon form of matrix, normal form of matrix, and how to find the inverse of matrix using Gauss-Jordan method. In next lecture, we are going to cover the consistency for system of homogeneous and non-homogeneous equations. Thank you.